Hello, so today we are going to do this problem, which is part of Leetcode Daily Challenge, sort colors. So this problem, we have an array of n objects that have 3 different colors, red, white, and blue. And what we want to do is sort them in place so that the objects of the same color are adjacent. So you'd have red, the object of red color together, then white together, then blue together. And here we represent the colors by integers. So for example, you can imagine red being 0, white being 1, and blue being 2. And we have to solve this problem without using any sort library function. Okay, so if we take a look at this here, we get first this unsorted one. We put the zeros first, the ones second, and then 2 after. So you can imagine these are the reds, these are the blue, and these are the white. These are the whites and these are the blue. Now they are asking us also to do it with a one-pass algorithm using only constant extra space. So without using extra space. You could do it a follow-up or you could do it immediately. But let's see first how we can tackle this. This is actually a known sorting problem called Dutch national flag problem. And we can just take a look at it like this. So it's basically modeled after the Dutch national flag problem because you would have red first, white second, and then blue second. That's sort of the idea here. Now, how do we tackle this? So the way to think about this is initially we have our array, right? Let me actually just do it like this. So we have our array, and then we have them in random order. I'm going to represent 0 with red and with R, and 1 with W, and then 2 with blue B. Okay, so initially you have the order mixed. So you may have like a white first, a red, a blue, a white, a blue, a red, 2 reds maybe, and then like this. And the goal, what we should do is end up with something like this: have all 3 R's together, have all 2 whites together, and then have all 4 B's after that. Okay, this is the order that we should end up with after sorting. Okay, so how do we do this? Well, what are we ending up with here, right? We are ending up with regions, right? First you have the red region, right? And then you have the white region, and then you have the blue region, right? And so what we can do is just define these regions. Initially they are empty because we don't know which one is which. And we can just examine each element, and if it's red, put it in the red region. If it's white, put it in the white region. If it's blue, put it in the blue region. Okay? So now the problem is just how do we arrange this? Well, we definitely know that we need to have a red region. So let's call it red region, right? And then we need to have some sort of blue region, white region. Okay, so this would be our red region, and then we would need to have sorry about that. So we'd have our red region, then we need to have our white region, and then our blue region. Okay, but where do we put the element that we haven't examined yet? Because initially we have just the element that we haven't taken a look at yet. So initially we have something like this. We need to check each element to know whether it should be in the red or the blue, white or the blue region. Well, the answer, you can put it anywhere you want. Okay, but for my case here, let's just have all the elements that we haven't examined yet. Let's have them here between the white and the blue region, just to make it easier. So this would be the unknown. Let's call them U, because we haven't examined them yet. We don't know the values. Okay, so initially, if you think about this array, initially all the elements are in this region. Initially they are all in the unknown region because we haven't examined them yet. Okay, so initially they are all here. Okay, but now each time we examine one, let's say we check 2, this is blue, right? And so we say, okay, this is blue, let's move it out from here and let's put it in the blue region. Okay, and then we examine 0. Where should we put it? Well, 0 is the red, so it should be in the red region. And 2, blue, so it should be in the blue region. 1 is white, so it should be in the white region. 1 is white, should be in the white region. 0 is red, should be in the red region. And now this region, the unknown region, is empty. So once the unknown region is empty, we are done, and we can just return. We have 0, 0, 1, 1, 2, 2. That's exactly what we would have ended up with if we use this, right? Okay, so that's the core idea, is to just initialize your regions. Initially they are empty, and then just add to each region as you need to. Now, how do we turn this into like a concrete algorithm? Well, what did we have? We had a red region, right? And then we had a white region, and then we had the unknown region, and then we have the blue region. Initially these are empty. This one is empty, this one is empty, this one is empty, and this one is the entire, all the values. So how do we represent this? Well, we can just say, we just need some pointers to represent each so that we can move between them. So we can just have this be 0, and this be some low value, right? And this be for the white region. Well, this is the start of the unknown region. We can call this maybe S for the start of the U region, and this is E for the end of the unknown region. And this is just the end of the array, because you can see here we put all the elements at the until the end of the array. And so when we move an element like 0 from this from the unknown region and need to put it to the in the white region, well, we can just swap. We can just swap the whatever is at the start region with here, and then just mark that element as and then just advance our start region, because we will need to always maintain that the S is the start of the elements that we have not examined yet. Okay, I think this will be more clear once we see the code, so let's just jump into it, and we will jump back and forth between the code and the explanation. But here is the drawing that will give us that we can follow. We have the red region, the same drawing that I had here. We have this, let's call this S, we said, and this is end. Okay, and this is the unknown region, the elements that we have not examined yet. Okay, so initially what should be the values? Well, low should be initially 0, because initially the red region is empty, so this should be 0. What about the start of the unknown region here? Well, initially it should be also 0, because remember we want to examine the entire array, right? Let's call this array A. So let's take the array that we want to examine. So initially, right, we should start, the unknown region should start from the first element, so it should be 0. Now what should be the end? Well, we want to examine all the elements, so the unknown region should go all the way to the end. So we should have this going to be the length of the array minus 1. Okay, and then that's pretty much it. We just need to specify what is n. N is just the length of the array. Okay, now that we have all the variables, let's just make this a little bit nicer, move them in the same line. N is the length of the array, like this. Okay, now when should we stop? Well, we should stop when we examine all the elements in the unknown region, right? That's when we should stop. And so what is the, how do we know that? Well, it's just when this end here is equal to the, when this start here is equal to the end, right? Because every time that we process an element from unknown, we shrink S. We increment S, we shrink it. So once we, like this, okay? So each time we process an element, we shrink start. We move this, and then when we process the second, we shrink. Now when we process the last element, both start and end would be at the last position. Okay, so when this one, the last time we increment the start, it's going to be bigger than the end. So we will keep going as long as it's smaller or equal to end, because that means there are still elements to examine. Now, if the element at the position we are looking at in unknown, if that's equal to 0, which means it's red, we should move it to the red region, right? Okay. Now, if it's equal to 2, that means it's blue, so we should move it to the blue region, okay? Otherwise, it means it's, what's the remaining possible value? It's just 1. So in that case, we should move it to, that means it's, so that means it's 1, which means it's white. So, which means we move it to the white region. So now all that is left is just to actually move the indices so that this works. Okay, so how do we do that? And at the end, the array would be sorted because we will just move the elements to their proper region, right? So when it's red, we should move it to the red region. How do we do that? Well, we know that this element, let's say, for example, low, the first instance, this was 0, and this was 0, right? And this was 0 as well. So we find that the element here is red. So it should be in the red region, which means we should just make this be 1, make this be 1. Because that means the red region is now 0 to 1, right? And so we could just do, what we do is we swap the position, we swap the values in the 0. Here it's a little bit, just because it's the first step, all of them are 0, but we'll see in the second step that it will make more sense, but we should just swap this value with the value at the 0 position. But more importantly, we should increment the low value so that this is 1, so that we say that the value at position 0 is actually part of the red region, right? And so we need to increment low. But we also need to increment the start for the unknown region because we just processed element 2, this value here, the first position, so we increment also start. Now we go to, now we go to this 0 here, because now our s is equal to 1. So this one value here is 0. So it's red as well. So that means this needs to be in the red region. Now again, we do the same swap, and then we advance. The low now for the red region is, sorry, this is 0 actually means it's, I think I messed up here. This 2 here was part of the blue region. Okay, so I just messed up this first one. So it was part of the blue region. It means we need to move it to the blue region. So we need the blue region here. Let's just, to make this easier for ourselves, make this 0, okay? And so we moved, so that worked, we moved this 0, and so this means now this needs to go all the way to 2. And now we need to move this here. So now it's 2, which means it needs to go to the blue region. Okay, so what does this mean? We need to swap the first value to be in the blue region, which means we need a of end and a of s. We just need to swap them. Okay, so the way this looks like is we will move this 2 to be in the end region, which means this 2 will move here. Okay, and now this end value that was previously 0, 1, 2, 3, 4, 5, now this end region is going to be 4, right? Because the blue region is going to have more, so we need to decrement this end here. Okay, because the unknown region, we just put this 2 in the blue region, so the blue region is now from 4 to 5, which is n. Okay, And now we move to the next element, which is 1, which is s now is still the same value, but it's still the same index, but different value, so it's 1. So we are in the white case, so we need to move it here. So how do we do that? Well, to move the white case, it's already in that position, right? We just need to move the pointer for the start of the unknown region. So now we just do this to be 3. Okay. And then we keep going. So now you can see already it's getting sorted properly. Now we look at 0, right? Because our s is now 0, 1, 2, 3, 4. Our s is now 4, so we look at 0. It's 0, so we need to swap, which means we need this to be here. So we swap. So we swap this position with the starting position. So 0 is here, and the 1 goes to this position, right? And then we increment low. So now low is up to 3, and that's exactly what we have here. 0, 1, 2 ends at 3, ends just before 3. And then start needs to be at 0, 1, 2, 3, 4, 5. It's at 4 now, right? Because we incremented. Okay. So it's at 5. So now you can see a unknown region is done because 5 is bigger than 4. So we exit and we are done. And this is now sorted. Okay. I know it was a little bit tricky to keep track of all the indices, but you can do it again for a couple of other examples just to see what it looks like. But it's all it is we have the regions, we put pointers in those regions, we start going through the unknown portion, and we keep moving elements to their proper region by just moving the indices and swapping until every element is in its proper region. We are done at that point. Okay, and that's pretty much it. So since we changed the array in place, we didn't use any extra space really, so we should be good. Now let's run this. Looks good. Let's submit, and it passes. Now in terms of time complexity, we are only using pointers, and each time the main pointers that move are the start and end, and each time we reduce by 1, and so overall it's O in time and O of 1 space. Yeah, so that's pretty much it for this problem. Thanks for watching, and see you tomorrow.